This is another practice test. It's not all around one subject. This is a sort of a general test. And like the last test, the answers will be at the end so you can kind of keep track of how you're doing on the way. And so here's question number 1. Where should out-of-round measurements be taken to get the most accurate result? A, top and bottom of cylinder. B, the top at 12.6 and 9.3. C, center of the cylinder bore. Or D, bottom of the cylinder bore. Question 2. What is the most likely result of failing to clean blind head bolt holes? Will it warp the cylinder head? Will the head bolts bottom out? Will the coolant enter the engine oil? Or will the head gasket shift inward? Question 3. The automatic transmission slips in reverse. This gal right here is upset about that. Does that mean the TCC clutch is stuck applied? That it has an erratic input shaft sensor? The ATF fluid level is overfilled? Or the LR servo has an internal leak? Question 4. Why do some systems need a transmission adaptive learning process? Is it to increase the line pressure? For clutch clearance shift timing? To reset the torque converter clutch speed reading? Or to burnish the torque converter? Question 5. A manual transmission makes a growling noise in all gears except fourth gear. Is it a stuck throwout bearing, a worn input shaft bearing, loose synchronizer rings, or a brindled ring gear bearing? Question 6. Why is it critical to check the pilot bearing? Does it maintain pressure plate tensioning? Does the bearing enable the clutch to release? Is it that a bad bearing can spin the input shaft, or can it cause a hard clutch pedal? Question number 7. The power steering on a 72 Mustang is very hard, but only in one direction. Binding pitman arm, counterclockwise belt slippage, wrong power steering fluid used, or a spool valve issue. Question 8. One of the steering rack bellows boots is oily. The bellows boot is cracked, or is the steering rack seal that has failed? Is it in normal condition on that rack, or is the pump reservoir overfilled? Question 9. A vehicle has a hard pedal only after the second pump. Does that mean the brake pads are warm? Air is trapped in the system? Master cylinder is leaking? Rear brake shoe adjustment. Question 10. What is the purpose of the metering valve in disc drum systems? A. Prevents rear brakes from locking up. B. Allows the rear brakes to engage first. C. Increases fluid pressure to the calipers. Or D. Alerts that there is pressure loss in one circuit. Here are your answers. The out-of-round measurements need to be taken at the top because that's where most of your wear is going to be. And it's really surprising. You know how many times years and years ago we used to throw rings and bearings in one just on faith. But the right way to overhaul particularly one of your old big block engines is to go ahead and have it bored 30 over and buy new 30 over pistons. And that way you'll have perfectly round holes and you'll have just a whole lot better job. Sometimes when we would build one, even though we deglazed the cylinder walls and all that, sometimes it would burn oil because the holes weren't quite round, But it's really surprising how an engine wants to run, and it wouldn't burn a lot of oil. But even on your new engines, a lot of the newer engines on Ford and GM, they had these bulletins that came out that said if their engine was not burning more than a quart of oil every 1,000 miles, they considered that within spec. And none of us like that, but one way or another. I mean, I've got this 2025 Ranger that's got 2,500 miles on it now, not 25,000, 2,500 miles on it, and I have yet to pull the dipstick on the thing. I'm just driving the thing on faith as I think of it. I probably need to open the hood on that truck and pull the dipstick just because it's smart to do that. Anyway, the maximum wear occurs at the top, so 12, 6, and 9, 3 are like clock positions, so you're going to be right under where the rings, right under the ring groove if it has one. You're going to measure it at the top. Of course, you can measure it here and you can measure it there and you can compare them all, but if any of them, this is the one that's the most likely to be out of round, and it doesn't matter what these are. If this one's out of round, you're going to need to do something about it anyway if you want to get a good engine overall out of it. Most likely result of failing to clean blind head bolt holes is that the head bolts may bottom out. And when they bottom out on that liquid's not going to compress, and it's either going to stop the bolt from getting tight so that it blows the gasket out right there where that one is, where that bolt is, or it's going to bust something. All right here is that's what happened. Somebody left fluid in that hole and they tightened that thing down, and because it didn't completely tighten up, they just kept cranking on it. At the college where I taught automotive for about 19 years, the diesel department down there, he had this big VT 906 Cummins, I think it was, VT 904, whatever the thing was, and his students were putting a head back on it, some of his students were, and somehow some liquid or oil or something got down in one of those bolt holes, and they couldn't get that bolt head to tighten down snug against the cylinder. They could still see space there, and so rather than pulling the bolts out and making sure there was no fluid or anything in the hole, they just kept cranking on it, and they just busted the block on that Cummins engine, and it was his trainer engine is what it was, which was a disaster for that. They couldn't use that engine anymore. But anyway, that situation happened to me in 1975, I guess it was, when I was working at that gas station, and I rebuilt the engine on that black Chrysler that my dad had traded that lady out of. And whenever I was putting the cylinder head back on, somehow or another I managed to trap some coolant. Just enough coolant was trapped in the bottom of that hole so that it didn't tighten against the cylinder head. And driving home after, the first time I drove it home after I got the rings and bearings and all that replaced in it, it blew the gasket on that corner of the head. And so I had to pull the head back off, and I had to make sure. What I like to do is take a blower with a sort of a small nozzle and stick it down in each head bolt hole or any other blind hole you're putting a bolt into, and blast that thing with air and make darn sure, and then look in it with your pen light and make sure there's nothing in that hole at all. Sometimes it's a good idea to go ahead and chase the threads on the things too, and blow all of that out, and then you're ready that way, So just keep that in mind. Fluid won't compress. Torquing a bolt into that blind hole, you can bust something, or it won't get tight. There's all kinds of issues with that. Automatic transmission slips in reverse. This servo, I said that low reverse. It's not always low reverse. Sometimes it's just reverse. This servo here, let's zoom in on that. Specific gear failures are usually tied to specific clutches, bands, or servos applied during that gear. This is a 5R55E, and that servo right there applies this band around that drum, and it's hooked to the you got your in your sun gears, you got your the basic sun gear, you got the sun gear, planetary gears, you got the sun gear, the planet gears, and the pinion. If you hold the pinions, which is the one that's got the little gears around the sun gear, you hold it still and won't let it turn. If you drive the sun gear, the ring gear runs the opposite direction, and vice versa. If you drive the ring gear, the sun gear spins in the opposite direction if you're holding the pinion gears. And so that's just basically how that kind of thing works. Anyway, for what that's worth, there it is. Why do some systems need a transmission adaptive learning process? Well, the clutch clearance shift timing is what that's all about. It adjusts the volume and timing of fluid application to ensure smooth shifts as internal components wear or are replaced with new clearances. The scan tools, particularly, Chrysler was a sort of pretty wise how they would put clutch volume index readings. And if you got used to looking at those clutch volume index readings on a Chrysler transaxle transmission, you could look at those numbers that it had stored for its adaptive learning and tell which one of the clutches was having to work the hardest to apply. And if the clutch volume index number was a lot higher than it should be, in other words, you would know the numbers that you usually saw. It's a good idea when you're doing any kind of scan tool work or scope work or anything like that, is scope and scan as many good cars as you possibly can that don't have problems. And that way, when you scope a car that does have problems of the same kind you scoped before, you'll basically remember what it would, you'll be able to pick out the bad numbers on the car you're scanning if you got one with a problem. Now, on a lot of the scan tools, it's cool as all get out, because these tablet scan tools, you can actually save screenshots. So if you go ahead and scan a bunch of vehicles, like say you're working on a lot of LS engines and Chevy pickups, scan those, lots of them, and make as many screenshots as you can and save those in a folder. You can put them on a jump drive or whatever. If you got a good scan tool that'll do that. And that way you've got you a library. Pico Scope's got all kinds of library functions. If you're using a scope and you haven't seen the number, the pattern on your cam and crank sensors or whatever, you need a good pattern to compare it to. That's the long and the short. So when I was working, before we ever had a scope other than an ignition scope at the Ford dealership, whenever Ford did not have data stream, and they didn't have data stream on anything before 1988, which I thought was kind of dumb because Chrysler and GM had already forged ahead with that. I would measure voltages on the sensors that came into the shop. Came into the cars. I'd measure the voltage on every pertinent sensor on that engine, and I would know what they were supposed to be. And I had what I had a long coat hanger with an alligator clip on the end that I could hook to my meter, and I had a piece of shrink tubing all the way down to the end, and it was sharpened on the very end, and it was needle sharp. And you could go into that wire without really causing a problem. Everybody says, oh, you need to put some, clear nail polish over the hole or something like that. Well, to be perfectly honest, I didn't ever worry about that in those days. I would pierce those wires and I'd look at my meter and I would know what each one sensor was supposed to look like, whether, like on the map sensor was supposed to be hertz. I didn't have a meter that would read that. Anyway, long and short of it is, if you know what a good one looks like, you'll be able to recognize the bad ones. That's why treasury agents look at real money. They don't study phony money. They study real money, so they'll recognize phony money. Learn from that. Manual transmission makes a growling noise in all gears except fourth gear. That's a worn input shaft bearing. The bearing right around the input shaft where it goes into the transmission. This bearing right here. Now you might notice when you're in fourth gear, there's no sideways pressure on that bearing. It's just spinning without any pressure on it at all. But whenever you're in all the other gears, any of these other gears, you're going through that cluster gear, and it's pushing this sideways. In other words, there's a lateral pressure on that bearing. Not in neutral. You're not typically going to hear it in neutral, but this is the way that thing works. And of course, there's your first gear and second and third and fourth and all that. But in fourth gear, fifth gear even, a lot of times it'll make a noise in that one because you still got pressure on that one. And of course, in reverse, you're not going to be going fast enough to hear it typically. But long and short of it is, it's going to be fourth gear. I had run into that several times. Now, sometimes if the transmission has run low on fluid, it will destroy not only that bearing, but it'll destroy the input shaft and the counter shaft. So it's really important to keep the fluid checked on a manual transmission, because if that oil leaks out of there and it's only leaking a little at a time, over time you're going to lose all your oil. Same way with your differential. You can actually wind up with low oil in the differential if you just got a leak that doesn't seem that bad because it's not making spots on the pavement. You need to be well aware of that. Keep that oil checked and all. But anyway, it'll be a worn input shaft bearing on that one. If it's quiet in fourth but noisy in all the other ones, your input shaft bearing is it. Why is it critical to check the pilot bearing? Well, that's because a bad bearing can spin the input shaft, and if it's spinning it fast enough, you're going to find a little dab of gear clash when you're trying to put it in gear. You know, of course, since reverse is typically spur gears, you're going to wind up, when you're putting it in reverse, it's going to bump. You know, the spurs are going to bump, and you'll have to let off the clutch just briefly and spin the gear a little bit to drop them in. But if you feel if you've got one that won't release, this can be the cause of it. Also, a warped clutch disc can cause that. I've seen that before. But anyway, so it's going to spin the shaft. This is where the pilot bearing rides. And you can see how bad pilot bearing, you know, that's the bushing, the bearing, and a different kind of bearing area it's sealed. This one right here is typically the most likely to fail. On these right here, the way we'd get them out was we'd pack them full of grease and then have a shaft that was exactly the right size to go in there and drive that shaft through there, and that grease would force that bushing out of there. Or they make tools to pull them out, but whatever. And these needle bearings, I had shown you before how I built a tool to pull those out. And then these right here, they got a little tool for that too. But anyway, but this thing ought to be totally free and not have any pressure to turn at all when you max the clutch, and it releases. That's the whole deal. Power steering on a 72 Mustang is very hard, but only in one direction. I have seen this, believe it or not. It's a spool valve issue, is what it is. This is a spool valve up here, and when you turn the wheel, the spool valve moves just a little bit, and it directs fluid over here to help you turn in that direction, and it directs fluid here to help you turn in that direction. Well, actually up in here. But the long and the short of it is, I had a 72 Mustang I worked on when I was at the Lincoln Mercury place in 1983. That car wasn't but about 9 years old at the time. It was a 72 model. And for some strange reason, I can't remember, I might have been resealing it. I pulled the steering gear out, and I took it apart. And I knew how to do that. I mean, I'd taken it apart and put it back together before. And I had done it successfully without any problem. But on this particular one, you see these threads? And there's supposed to be a lock nut there that's not shown. Those threads are how you adjust that spool valve, and that spool valve's got to be adjusted just exactly right, where that thing is absolutely going to have a lot more power turning one way than the other. When I put the one back together on that 72 Mustang I was working on, as soon as you started the car, the wheel would spin all the way to the right. And I kept fooling with it and adjusting it, and I never could get it right. It may have been something wrong inside the gear, but the problem was a whole lot worse after I tried to rebuild the gear than it was before, and I never could figure it out. So we got another gear from a salvage yard and put on there. Anyway, that was one of those that I learned a heck of a lot on that. But anything, even on your steering rack, there's a spool valve in there, and it basically is going to direct the fluid back and forth to help you turn and all that. One of the steering rack bellows boots is oily. You got fluid in here. There's not supposed to be any fluid out here on either side, only in here. You got a center seal, you got an end seal, you got a power cylinder, and this right here, this slides through these seals, but this seal is part of the rack. And so as fluid is directed in here, it helps you turn that way, and as fluid is directed in here, to help you turn that way. Well, if there's any oil out here, there's not supposed to be ever any oil out here, and if it's dripping from these boots, one of these seals has failed. That's pretty doggone simple. Vehicle's got a hard pedal. Now, I didn't write this question the way I should. What I should have said was, the first time you mash the brake, the pedal goes closer to the floor. It's firm, but it goes closer to the floor. The second time, it catches right on the top. That's the way I should have written this question. I messed up when I wrote the question, and so I didn't, I actually didn't bold the answer on that. But it means your rear brake shoes need to be adjusted. That's the answer to this one here. When the rear brake shoes aren't adjusted properly, it'll require 2 pedal applications to get a full pedal. First pump takes up the space. The second one is whenever you actually are applying the brake. And this is a duo servo brake system, as other ones too. And this one is really susceptible to that. But that's why you got to adjust those brakes out there to where they're really, really close to the drum. If you just pop all the springs and everything on there and screw your adjuster all the way in, if you be and you slap that thing, that drum back on there, then you're basically going to have a low pedal and then a high pedal. I mean, it won't be spongy the first time. It'll be hard both times, but you'll hit it and then it comes back up. That's going to be that. And my sister-in-law had a Taurus that she was driving. She came for a visit from Tuscaloosa, and she said that the Taurus needed rear brakes put on it, and the shops that she went to up there wanted to charge her $300 to do the rear brakes. And because she was my sister-in-law, while she was in here talking to my wife, I jacked that car up in the driveway, and I went and bought a $16 pair of set of brake shoes, and I came and I popped them on there in about 30 minutes. And of course, I had to be really careful and adjust those so the pedal would feel right, you know. Anyway, by the time I was through with that, I mean, she wrote me a check for $20, you know. But with all due respect to the people in a shop, you know, I don't know how you could even squeeze $300 labor out of a rear brake job on a vehicle like a Taurus, you know, like that. That doesn't make any sense. I mean, or just about any vehicle. Of course, you know, some of them are more trouble than others, but that Taurus was just downright easy. I mean, it was one of the easiest brake jobs ever. But, you know, with all due respect, I know shops have got to make money, you know, and I've worked at dealerships and I've worked at independent shops and all that kind of thing. And there is a bottom line. But this one guy that I knew that owned a tire store for years and years and years and years and made a lot of money, he was always extremely fair on his pricing. And I sent just about everybody I could to him. There's another guy that's opened some shops over here. He owns several shops. And when I send people to him, it seems like they always have to pay big, giant shop bills for stuff. This one guy went over there. I sent him over there to that new shop to get a blower motor problem fixed on his truck. They put a blower motor on the truck and I think they had to replace the connector on the blower motor. They charged him $550 to replace a blower motor. And it's just right under the dash. I mean, you can change it out in 20 minutes, you know. Anyway, that's just, I don't want to be hating on everybody that charges a lot of money, but some of that stuff seems excessive. Like I say, I've done it both ways. I mean, we've worked on stuff like that. What's the purpose of the metering valve in disc drum brake systems? Well, a metering valve delays the front disc brakes momentarily so the rear drum brakes engage first, and that keeps nosedive from happening as bad, keeps the vehicle stable when you're just doing light braking, particularly on slick pavement. A proportioning valve limits rear brake pressure during medium to hard braking so the rear wheels don't lock up before the fronts. Now, sometimes you'll see proportioning valves, one in each brake line going to the rear brakes. Now, some GM cars used to do that. It was just one little, it just looked like a little filter or something. It was a proportioning valve going back there. But this is a combination valve that's got the metering and proportioning valves built into the same block. And that would be like right here in this silly little diagram right there. And so you can see it, you know, and I had a picture of it in the original slide and all. But one way or another, I just wanted you guys to run through another 10-question test. I hope this did you some good. I hope you enjoyed it. And let me know what you thought about it and if you got any good out of it. We'll talk to you later.